Hello students and welcome to this module where we will see relation between direction cosines of a line. So we know direction cosines are L, M, N. Let us try to see relation between them. Now students, we have this as a theorem. Let us see what is statement for the theorem. If L, M, N are direction cosines of a line, then L square plus M square plus N square is equal to 1. So students, this is very important statement which says for element of a line L square plus M square plus N square always turns out to be 1. Let us try to prove. Now before we start, let us consider a line L which makes alpha, beta, gamma as direction angles. So consider a line L passing through origin and having direction cosines L, M, N. So students, we know if P x comma y comma z is a point on line L, so there is a point P which is x, y, z. Now we can assume length OP, in the diagram you can see length OP as R. Okay students, now the position vector of point P will be OP bar, which is given by x I cap plus y j cap plus z k cap. So as we have assumed P as x, y, z, we can say this is the position vector. Okay. Now if alpha, beta, gamma are the direction angles of line OP, then we can say L is cos alpha, M is cos beta and N is cos gamma. Fine students. Now OP bar dot I cap. OP bar is a position vector of P. So we get x I cap plus y j cap plus z k cap dot I cap. And this will turn out to be x. Fine. Now let us call this statement 1. OP bar dot I cap can be obtained using basic definition of dot product, that is magnitude of OP bar, magnitude of I cap, that is 1 into cos of alpha. So here we get R cos alpha. Let us call this statement 2. Now students, if we look at 1 and 2, we can say x is equal to R cos alpha. Right? Now this is obtained from 1 and 2. Now students, similarly we can calculate y as R cos beta and z as R cos gamma. Now therefore we say OP bar was x I cap, which will become R cos alpha I cap, y j cap will become R cos beta j cap and R cos gamma k cap. Okay students, now we know that OP bar dot OP bar will be magnitude of OP bar square. Yeah, so we get R cos alpha whole square plus R cos beta whole square plus R cos gamma whole square is equal to R square, and this will become R square cos square alpha plus cos square beta plus cos square gamma is R square. Yeah, when we cancel out R square on both sides, we get cos square alpha plus cos square beta plus cos square gamma as 1. And cos alpha students is L, so we get L square plus M square plus N square equals to 1. So here we prove that for direction cosines, sum of squares is always 1 for any line in three-dimensional geometry. Okay, so once we have proved this result, let us see if we can get something else. Yeah. If length OP is equal to R and P x comma y comma z is a point on line L, then we know that R bar is magnitude R into R cap, right? And this will give R cap as R bar upon R, right? And let us proceed further. So unit vector R cap will be x upon R I cap plus y upon R j cap plus z upon R k cap. Fine students, therefore we can say cos alpha I cap plus cos beta j cap plus cos gamma k cap. So if you looked at this statement carefully students, R cap is there on left hand side and right hand side contains direction cosines with I cap, j cap, k cap. Right? And this means if unit vector is resolved in terms of I cap, j cap, k cap, then the coefficients of I, j, k are direction cosines of a vector. Fine. So if we want to summarize all these results, we can say first pointer, for any line having direction cosines L, M, N, L square plus M square plus N square is always 1. Okay students. Second pointer, if alpha, beta, gamma are direction angles of a line, then cos square alpha plus cos square beta plus cos square gamma will be 1. Now as it is very much clear, this is obtained from first statement only, but for problems we require relation between alpha, beta, gamma. Now the third pointer says, for a unit vector in space, coefficients of I cap, j cap, k cap are direction cosines of that vector. That means if we calculate coefficients of ijk students, they will represent direction cosines for a unit vector. Fine. So in these 3 pointers, we have these as important expressions. Okay. So if we remember, we can solve the problems very easily. Fine. So here we studied what is relation between direction cosines. Thank you.